All right, guys, couple weeks off, and we're finally ready to get back into the swing of things. So today we're going to be talking about section 3.1 from the book. And this is really all about graphing a new shape. We're going to be graphing f of x equals ax squared. And a is going to change, but the x squared is going to stay x squared. So this is a new graph that we've dealt with a little bit, but we've never really actually drawn it or looked at it specifically. We've just dealt with it algebraically. So kind of the big question today are, what are some of the characteristics of this graph that's in this form? So what I've got here for you first, and what you probably want to put in your notes is this is the parent, we call this the parent function. Just like, remember in chapter 1 when we learned about absolute value graphs, and the basic absolute value graph was f of x equals the absolute value of x. There was no adding, subtracting, multiplying. It was just an x and an absolute value, and it looked like this. It was a V shape, right? Well, today we're going to be looking at the parent function, f of x equals x squared. So nothing right now, at least to start with, nothing's happening to x squared. We're not multiplying anything. We're not adding anything. All we are doing is x squared. And that looks like this shape right here in front of us. It's called a parabola. Parabola. This shape is called a parabola. You're going to hear that word a lot. It's kind of the shape of a U. Actually, it's very much the shape of the U, just without the weird little tail, right? So it's U-shaped. A couple of things that we really care about, a couple of important characteristics are this point right here. Okay, that point right there, well, first of all, that point is 0, 0, right? And that point is called the vertex. So it's the lowest point on the graph. If my parabola was upside down, the vertex would be the highest point on the graph. But that's an important characteristic. That's one of the things that we care about. Another important thing to notice is all of these parabolas have something in common. If I were to draw a line, I don't like that line. Let's get rid of that color and let's make something a little bit more standing out. If I were to draw a line straight up and down right through the vertex, if you notice the left side of this graph, this side over here, is a mirror image of this side over here. So the left and the right sides match each other. They're called it's a mirror image. And this line going up and down the middle, we don't actually draw it very often. We know it's there because it's where our image has this mirror happen. But that line right there is called the axis of symmetry. It's kind of the line that would be the mirror image, right? And in this case, well, in all parabolas, it goes straight up and down. And it actually has an equation. Like this one would be x equals 0 because it goes straight up and down through the x value 0. So my axis of symmetry, my line, my mirror line that goes up and down the middle is x equals 0. Again, we don't draw it very often, but it's something the book is going to reference. It's something the ACT is going to reference, the end of level test. All of these different things are going to use that word, axis of symmetry. So I want you to know what it looks like, even though we're not going to draw it very often. If you notice the right side of my graph, this yellow part, as I move to the right, my graph is increasing, right? So over here, my graph is increasing. But on the left-hand side, my graph is going down as I move left to right. So over here, my graph is decreasing, which we're not going to use all the time, but it's something interesting about the graph, especially because in the past, all you've really dealt with are lines, which this line is always increasing. This line is always increasing, but now we have this function that in some areas it's increasing and others it's decreasing, which means it has a lot more application in the real world, which we'll kind of get around to later. So the highlights, the parent function, the vertex is right here at 0, 0. It's shaped like a U. It's called a parabola. And it has this axis of symmetry, this imaginary line that goes straight up and down the middle. And that line we would call x equals 0 on this example. All right, so what happens if I put an a or some other number in front of x squared? What happens if I put a value in front of that x squared? So for example, what happens, let's see, let's get down to my other graphs here. We don't need to go through all that identifying. We'll do that in the classroom. But so what happens, for example, if I have, instead of f of x equals x squared, what if I have something like f of x equals 3x squared? Or what if I have f of x equals 1/4 x squared? Or what if I even have f of x equals like a negative number, negative 3x squared? I want to know what that does to my graph. What changes instead of being this nice perfect U right in the middle? What happens if I put a number in front of x squared? So the way we're going to look at this, I'm going to go to Desmos. And you should, on your screen, you should see this blue line right here. Where'd it go? There we go. Stop showing me the pink line. I have this blue line, right? This is my parabola. It's f of x equals x squared. I've got my vertex right here at 0, 0, and then I go up to the right and I go up to the left. What happens though if I put something in front of x squared? So instead of just x squared, I'm going to make this pink graph, and let's put a 3 in front of it. So the blue one, go away right there. The blue one is my normal graph. The 3x squared is that pink one. And if you notice, it's still a U shape. It still goes through the vertex is still the same. It's still at 0, 0, but it's a lot skinnier. It's a lot skinnier and a lot taller. So that's kind of interesting. What if instead of a 3, let's maybe put something like a 5. Well, that made it skinny too. Instead of 5, let's put something like, let's do like 100. I wrote 10 instead of 100. So it's even skinnier. It's still a U shape. If I zoom out, it's still in the shape of a U. It still has the same vertex. The only difference is it's a lot steeper. Which kind of makes sense if you think about it. If you think about going back to what you learned last year, y equals x was this line that just went up 1 over 1, right? But if you did something like y equals 4x, that changed the slope. It made your function a lot steeper, which is all that a is doing that's in front of the x squared. It's making our function steeper, which makes it look skinnier, all right? So the a value is kind of like, it's kind of like the slope. I'm not going to say it is the slope because it's kind of like the slope. It makes my function steeper, right? Well, what happens, let's go ahead and go back to Desmos here, and instead of 10x squared, let's do a fraction. Let's do like 1/2. So if you look at my pink function there, instead of being steeper and skinnier, now it's a lot wider. It's like it got fatter. So let's change it to 1/3. It gets even fatter. Let's change it to 1/4. It gets even fatter. Let's change it to 1/10, and it gets even fatter. So again, if you look at it kind of like a line, it's kind of like your slope is getting flatter, which again makes sense, right? Because if you had y equals 1/4 x, that means that instead of going up 1 over 1, you would only go up 1 over 4. And so your line would also get a lot flatter, just like our quadratic does, just like our parabola gets flatter. So the number 3 makes my function steeper and skinnier. The number 1/4 makes my function flatter and fatter. Hey, that rhymed. What about a negative number? Let's see what happens if I make this. We'll just do something like negative, I don't know, 3. Let's do negative 3x squared. And when I look at my picture, it's still a u. It is skinnier, but it's also flipped upside down. So that negative number in front takes my u shape and turns it upside down. So if I go back to my, if I look at this negative 3 right here, that's, again, kind of like having a negative slope, right? If I have a negative slope, my function, instead of going up and to the right, it goes down as I go to the right. And it's going to do the same thing to my parabola. Instead of my u going up, that negative value is going to make my u shape go down. It's going to flip it upside down, all right? So let's make a couple of notes here, something that you need to put in your notebook. So if f of x equals x squared, that gives us a parabola, right? That gives us a parabola. It has a vertex at the point 0, 0. And I don't want to say it has a slope of 1 because it actually doesn't. But it has that regular U-shaped slope, right? So now if I say, what happens if I have f of x equals ax squared? Well, it kind of depends on what a is. So put this in your notes. And we're going to say if a is a number bigger than 1, so if it's like 2 or 3 or 4, that is kind of like it changes, and in quotes, I'm going to put my slope. And we're going to say it makes my parabola, it's going to make my U shape skinnier. I think that's a good way to word it. It changes the slope. It makes my U a skinnier U. And I'm going to show you how to actually find those numbers here in a minute. What happened if A was a fraction? What if A was something like 1 over 4 or another fraction? What did that do? Well, that also changed the slope, but this time it makes your U fat and flat, right? It makes the U fat and flat. So instead of being a tall, skinny U, it's a really short, fat, chubby U. All right, now what happened if A was negative? What if it was a negative number? What did that do? Well, that was the one that flipped it upside down. So it makes my shape an upside down U. So it turns it into, I mean, it's not an N, right? But it's an upside down U. It kind of looks more like a mountain instead of a valley. All right, so now putting this, if you need to pause the video, finish writing that down, but that's what my A value is going to do, okay? And I'm going to keep telling you, the words I'm going to use are it changes the slope, even though slope mathematically really doesn't mean anything. But what I'm implying is that it changes how steep the function is. So if it wants me to graph the function 2x squared, in order to do that, first of all, the only thing I have is a 2 in front of the x squared. So I know that my function is still going to be at 0, 0. So I'm going to start at 0, 0. Okay, that's step 1. I'm going to start at 0, 0. Normally, if that 2 wasn't in front, maybe what we should do is graph x squared first. So in black, we're going to graph x squared. The way x squared works, and if you want to add this to your notes, x squared graph, you start at 0, 0, and then you go up 1. I don't want to use words. I'm going to do this. You're going to go up 1 and to the right 1. So I'm going to go over 1, up 1, and that's going to be a point. Then I'm going to go over 2, but this time I'm going to go up 4. So I'm going to go over 1, 2, and up 1, 2, 3, 4, and that's where I'm going to put my point, is right there. And that's going to be 1/2 of my graph, and it's going to be this shape right here. Now the other side is really easy because it's the exact same. I'm going to go up 1 over 1 the other direction, but then I'm going to go over 2 and I'm going to go up 4 the other direction. And it's going to look kind of like a mirror image of each other, right? So that's my normal x squared. But if I want to graph 2x squared, here's what I do. All right, so I still start at 0, 0. I start in the same place. We'll do this one in blue. Step 2 is I'm going to go over 1 and I'm going to go up a. Whatever a is, that's how far I'm going to go up. So I'm going to go over 1 and I'm going to go up 2 because a is 2. That's going to be my first point right there. Then my next point, I'm going to go over 2 and I'm going to go up 4 times a. So I'm going to go over 1, 2, and I'm going to go up. Well, a is 2, right? In this problem, if a is 2, 4 times 2 equals 8. So I'm going to go over 2, up 8. I'm going to go over 1, 2, and I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So my other point is going to be clear up here. And then I'm going to draw my picture, this side of it, which is what we expect, right? It's going to be steeper, which is going to make it skinnier than my original graph. Now the other side is going to be exactly the same. I'm going to go, instead of going to the right 1 and up 2, I'm going to go to the left 1 and up 2. And then I'm going to go to the left 2, 1, 2, and up 1, 2, 3, 4, 5, 6, 7, 8. Well, I think I went up. Maybe my last one wasn't up high enough. I don't know. Maybe I counted wrong. We'll pretend I didn't. So that's what x squared or 2x squared looks like. Okay. So when it says to compare the graph, all I'm going to say is that my slope is 2, or I'm going to say that it's skinnier. Either of those tells me that you understand what I'm talking about. Okay, the slope, instead of just being 1, the normal slope, it's multiplied by 2. Or you could say that it's a skinnier graph. All right. Okay, let's try another one. Graph h of x equals negative 1/3 x squared. Oh, wow. All right, so we're doing a negative and a fraction at the same time. So we're going to do those same steps. I'm going to start at 0, 0. So I'm going to start right here in the middle. And then instead of going over 1, up 1, I'm going to go over 1. Look, that was step 1. Step 2. I'm going to go over 1. And remember, this is a negative number. So instead of going up, I'm going to go down whatever a is. Well, a in this case is 1/3. So I'm going to go over 1, and instead of going down 1, I'm only going to go over 1 and down 1/3, which is only like right here. That's like, I can barely even draw that. Well, if I zoom in, maybe that'll be easier. 1/3 like right there. And then my next step is to go over 2, and I'm going to go down 4 times a, which is 4/3, because 1/3 times 4 is 4/3. So I'm going to go over 1, 2. Now 4/3 is 1 and a little bit more. So I'm going to be like right here. So my graph is upside down, and it's going to look something like that. Oh, maybe that wasn't very good. It's going to look something like that, okay? Now I'm going to do the same thing the other direction. I'm going to go over 1, and I'm going to go down 1/3. And then I'm going to go over 2, and I'm going to go down 4/3. And when I graph this side, it's going to look, wow, that looks so much better than my other one. I'm going to erase that because it looks so bad. I wish I could do as good of a job. Oh, that was a little bit better, right? So normally my graph would have looked something like this. That's what my normal graph would have looked like if it was upside down. But if it was right side up and normal, it would look something like this. So when it asks me to compare my graphs, what's different is it's upside down, right? Instead of going up, it's going down, and it's fat and it's flat, right? It has a slope of 1/3, which really doesn't, again, it doesn't mean anything mathematically, but it does mean something to me. It means that you recognize it's not as steep as the other one, it's flatter, okay? All right, let's, well, you don't have a partner because you're just watching this at home. Otherwise, you'd be sitting here in class with me. So really quick, why don't you pause the video right where we are, and I want you to try to graph, why don't you try to do A and B? Try to graph those ones, and then come back when you're done. Okay, so what you should have done for graph A, I've got this 3 in front of the x squared. So that means my A value is 3. So I'm going to start at 0, 0. And then my next point is going to go over 1. And instead of going up 1, it's going to go up 3. So over 1, up 1, 2, 3, my point's going to be right there. My next point is going to go over 2. And it's going to go up. Remember, this one needs to go up 4 times A, which is actually 12. So I'm going to go over 2, and I'm going to go up 12, which is clear up here, barely on my graph at all. So when I connect these, don't try to draw, it always tries to draw a line when I do this one. And I don't quit drawing a line. This one is so steep, it's hard to get it to draw the curve. But I want to reflect it on the other side. So I also want to go over 1, up 3, and over 2, up 12 on this side. And I'm going to try to make it look like a curve. See, that was a little bit, I'm a lot better drawing to my left apparently than my right. I don't know what that's about. Okay, so if it wanted me to compare, I would say that it's skinnier, skinnier, I think that's how you spell it, right? Or you could say that it has a slope of 3, which I'm going to say it again, that doesn't mean the same thing as when it's a line. But slope doesn't mean anything. It just describes how steep it is. So you could say it has a slope of 3, or you could tell me that it's skinnier. Part B has a -5 in front. So I'm going to go over, well, first of all, I'm going to start at 0, 0, right? That's always my starting point. And then I'm going to go over 1, but because of that negative, I'm going to go down whatever my A value is. And my A is 5. So I'm going to go over 1 and down 1. Oh, let's see. 2, 4, 5 is right there. So I'm going to go over 1, down 5. Then I'm going to go over 2, and I'm going to go down 4 times A, which is 20. So I'm going to go over 2, and I'm going to go down, let's see, 16, 18, 20 is right there. So again, I'm barely, why does it keep doing this to me? It's supposed to be a curve, but it keeps wanting me to draw like straight ones. And then I'm going to do the same thing the other way. Over 1, down 5, over 2, down 20, and I'm going to draw this curve. And then it wants me to compare my graphs. Well, it's upside down from what it normally is, and it's skinny, or I could say that it has a slope of -5. Either of those tells me the same thing, okay? All right. We've got some more problems for you to try. The problem is you're not here. So I can't really, I can't help you if you try them wrong, but let's go ahead and I want you to try 2 more. I want you to try number 4, and I want you to try number 8, because those ones have fractions and we haven't done the fraction one yet. So try to graph 4 and 8, and then pause the video and come back after you think you have the right answer. Okay, so for number 4, if this is my graph, I start at 0, 0, and I'm going to go over 1, and I'm going to go up A. Well, A is 1/3, so I'm going to go over 1, but instead of going up 1, I'm only going to go up 1/3, which is like right there. Then I'm going to go over 2, and I'm going to go up 4 times A, which is 4/3. So I'm going to go over 2, and I'm going to go up. There's 1, there's 2, so 4/3 is like right there. And then I'm going to draw this curve. And now I'm going to do the same thing the other way. I'm going to go over 1, and I'm going to go up a tiny bit, 1/3. And I'm going to go over 2, and I'm going to go up a little bit more. And I'm going to draw this curve. And it's going to look something like that. See, that's like the best one I've done so far. But still, it looks better going to the left. I don't know. Maybe left-handies. Maybe you're better at drawing your arrows to the right. I'll have to ask you in class. So when it asks me to compare, it's still going up like it normally would, but it's kind of like I have a slope of 1/3, or it's flatter, or it's fatter, right? It's fat and it's flat. It's not as steep as the normal one. Okay, 8 has a negative 1/4. Well, I know it's going to go upside down, so let's start like this. It's going to start at 0, 0, and I'm going to go over 1, and I'm going to go down 1/4. So over 1, down 1/4 is going to be like, this is even flatter than the other one. I'm only going to go down 1/4. Then I'm going to go over 2, and I'm going to go down 1/4 times 4. So over 2, 1/4 times 4 is just 4, right? 4/4 is $1. So it's going to look like that. Maybe that's too steep. It's going to look, oh no, I'm erasing. This is a bad, rough day, guys. I'm still erasing. What is going on? It's going to go something like this, right? Okay. Going the other direction, I'm going to go over 1, down 1/4, over 2, down 1, and it's going to look something like this. Okay, so when I compare, well, this time I'm upside down, and I could either say that I have a slope of negative 1/4, or I could say it's flat and fat. Either one of those works for me. I don't care which way you put it. They tell me that you understand why the picture is different, all right? Okay, your homework assignment. Where are we? Homework. I want you to do 3 through 12, 17 through 18, 20 through 22. Give those a try. Bring it to class. Email me, whatever you need to do if you have questions.